solving quadratic inequalities. So what I want you to be able to do is compare them to linear inequalities. So think about an equation you might have seen, something like 2x minus y is less than 12. This is a linear inequality. So what we would do to solve that is graph the line, making sure it's dotted because this is just a less than, and then test which side of the line that we should shade on. Very similar to solving a quadratic inequality. Step 1, graph the quadratic. Step 2, test a point inside the parabola and outside the parabola, and then shade the area that's true. So the key here is remembering how to graph a quadratic equation. Our first quadratic equation is in vertex form. So remember, to get the vertex, you look inside the parentheses. It's the opposite of what we think. Outside, it's normal. So our vertex is 2, 1. Because our quadratic, right here, has a coefficient of 1, we can graph this one using those t-chart values from the parent function. Negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. If there were a coefficient in front of my binomial squared, then you could make a t-chart, pick two values on either side of the vertex. So for example, because 2 is our vertex, the x-coordinate, I would use 0 and 1, and then I would use 3 and 4. So two values smaller, two values bigger, and just make the t-chart, substitute into the equation, and graph from there. So I plot my vertex, 2, 1, and then now these are directions as opposed to ordered pairs. So this one tells me left 2, up 4, left 1, up 1. 0, 0 represents the vertex, so the next one is right 1, up 1. And our final direction is right 2, up 4. Make sure your parabola is rounded at the bottom. And before you graph your parabola, you should ask yourself if it's solid or dotted. I usually forget to do that until after I've got it graphed. Right here we look at our inequality. Y is greater than or equal to. So that tells me my parabola should be solid, which is nice because now I don't have to go back and fix it. All right, second is test a point inside the parabola and outside. So I picked 0, 0. I really like checking 0, 0. Those are easy numbers to work with. So this one's outside the parabola. And for my ordered pair inside the parabola, I picked 2, 2. Remember, you can pick any point inside and outside the parabola. Be careful that you don't pick any that are too close to the boundary, because depending on how accurately you sketch your parabola, you may get one that should be outside, but you thought it was inside. So I would stay away from ones that are too close to the boundary. All right, so for 0, 0, we substitute that for x and y, and then evaluate and see if it's true. 0 minus 2 is negative 2, squared is 4, plus 1 is 5. 0 is not greater than 5. So then we test 2, 2, substitute 2 for y and x. 2 minus 2 is 0, squared is 0, plus 1 is 1. 2 is greater than 1. So it checks that the outside is not shaded and the inside is. So that's what the solution for our quadratic inequality is. This question, I'm going to change it up a little bit. Instead of y is greater than or equal to, because we had that last time, I'm going to change this to just a less than. So we're going to have y is less than x squared minus 2x minus 15. So we'll take a look at solving and graphing that one. This is in standard form. So in order to get the x-intercepts, I'm going to check to see if it factors. Here in parentheses are listed all of the different ways that you can find the x-intercepts. I like factoring. I think it's easier and faster than the quadratic formula. So I always check for factoring first. So this is the t-chart method. We're looking for what multiplies to negative 15 and adds to a negative 2. Well, for 15, I immediately think 3 and 5. And because I know it needs to add to a negative 2, I want the greater number to be negative. 3 times negative 5 is negative 15. And 3 plus negative 5 is negative 2. So I can go ahead and factor it x plus 3, x minus 5. Setting it equal to 0 gives us the x-intercepts. So then we solve using the zero product property. Either x plus 3 is 0, and I would have 0 times something equals 0. Or my other option is x minus 5 equals 0. Looking at that, we would have 0 times something still equals 0. So that's how the zero product property works. Solving each of my equations, I subtract 3 and add 5. So those are my two x-intercepts. Next, I'm going to find the vertex. Once you have your x-intercepts, you can average them to get the x-coordinate of the vertex. The other way to do it is because it's in standard form, you can use the formula x equals the opposite of b over 2a. But again, because we've already got it factored, I've already got those x-intercepts, I think it's faster to just go ahead and add your x-intercepts and divide by 2. Again, this is the x-coordinate of the vertex. So negative 3 plus 5 is 2, divided by 2 is 1. To find the y-coordinate of your vertex, you substitute it back into your equation. So we had 1 squared minus 2 times 1 minus 15. 1 squared is 1, minus 2 is negative 1, minus 15 is negative 16. So our vertex is 1, negative 16. For the y-intercept, because it's in standard form, the simplified version, or the quick way to get the y-intercept, is just to look at your c value. Think about, remember, substituting 0 for x and solving for y gives you your y-intercept. When you substitute 0 into this equation for x, this term goes to 0, this term goes to 0, and all we're left with is c. So that's why that shortcut works. Now looking at my vertex and my y-intercept, those aren't going to fit on a 10 by 10 graph. So I'm going to go ahead and scale this by 2's. So when I'm plotting negative 3, 0, it's going to land here. 5, 0 is going to land here. My vertex was 1, negative 16. So that's right here. My y-intercept was 0, negative 15. And then in order to get 2 points on either side of my vertex, I'm going to go ahead and reflect that y-intercept across my axis of symmetry, or kind of around the vertex. So we have a tall, skinny parabola. And what was I supposed to ask myself before I graphed it? Solid or dotted? This one should have been dotted, so I'm going to regraph that one. So now learn from my mistake. All right, so we have a dotted parabola. All right, so there's our parabola, dotted because it's just less than. All right, so these equations down here, these inequalities need to be fixed as well. We flipped around our inequality. 0, 0 is inside the parabola this time. 10, 0 is outside the parabola. So let's see what happens when I substitute 0. Well, 0 minus 15 is negative 15. Is 0 less than negative 15? No. So right now it's looking like we should shade outside the parabola, but let's double check. Substitute 0 for y and 10 for x. 10 squared is 100. 100 minus 20 is 80. 80 minus 15 is 65. Is 0 less than 65? Yes. So we should shade outside the parabola this time. Alright, so there's our solution for this quadratic inequality. That is it. As long as you can remember how to graph those quadratics, the inequality part itself is pretty straightforward. Hope you had a great weekend. We'll see you on Monday.